Hi students and friends, this is your host and teacher Sayyid Ayazuddin Haider. You are watching Learn and Teach by Sir Ayaz. So I was doing O-level past papers and this time I have selected CIE Chemistry 5070 paper 4. For this video I have selected the paper 41, variant 41, and it's of May-June 2023. It is paper 4, which is alternative to practical. So you must answer on the question paper. No additional materials are needed. Instructions for this paper is answer all questions. Use a black or dark blue pen. You may use an HB pencil for any diagrams or graphs. Write your name, center number, and candidate number in the boxes at the top of the page. Write your answer to each question in the space provided. Do not use an erasable pen or correction fluid. Do not write on any barcodes. You may use a calculator. So it means there are some calculations. So you need calculator for doing those calculations. You should show all your working and use appropriate units. Some information in this paper, that's total mark for this paper is 40. The number of marks for each question or part question is shown in brackets. Notes for use in qualitative analysis are provided in the question paper. We have this kind of note for the qualitative analysis. These are the tests for anions. So this for anions. Then you have list for the test of aqueous cations, test for gases, last but not least, flame test for metal ions. So let's continue. Here's question number 1. A student uses chromatography to separate the dyes in a food coloring. Figure 1.1 shows the apparatus the student used. Here is apparatus X, which is beaker. You have solvent, you have start line, chromatography paper, you have spots for the dyes, and there's a lid to prevent the loss or evaporation of the solvent. Name apparatus X. It's a beaker, so you'll write beaker here. B. State why it is important to have a lid on X to prevent the evaporation of solvent from the beaker. C. State why the start line is above the level of the solvent drawn in pencil. So a straight line should be above the level of the solvent because so that the dye does not dissolve of paper into the solvent. And why we are using pencil in order to draw the level start line, because the pencil does not dissolve in the solvent. So that dye does not dissolve of paper into solvent. Pencil is insoluble. In the solvent. Moving to next part. D. The RF value of one of the dyes in the food coloring is 0.6. In the separation, this dye travels 5.7 centimeter. Calculate the distance traveled by the solvent during the separation. So you know that in order to calculate the RF, we need to divide the distance traveled by the dye with the distance traveled by the solvent. Distance traveled by the solute. Here in this case, it's a dye divided by distance traveled by the solvent. Putting the values, RF is 0.6 is equal to 5.7. And let's consider X as the distance traveled by the solvent. So X is equal to 5.7 divided by 0.6. 5.7 divided by 0.6. What you will get? You will get 9.5. 9.5 centimeter. Moving to next question. Question number 2. White vinegar is a colorless solution containing ethanoic acid. Student titrates 0.4 mole per dm cube aqueous sodium hydroxide with 2 samples of vinegar A and B. Student does 4 titrations, 2 with A and 2 with B. The student, step 1. In step 1, uses a volumetric pipette to add 25 centimeter cube of 0.4 mole per dm cube sodium hydroxide to a conical flask. Step 2, adds 5 drops of an indicator to the conical flask. Step 3, adds A from a burette while swirling the contents of the flask, adding drop by drop near the end point until the solution just changes color. Step 4, empties the conical flask and rinses it with distilled water. Step 5, repeats steps 1 to 4. Step 6, repeats steps 1 to 5 using B instead of A. A part 1. Figure 2.1 shows the burette readings for the 2 titrations with vinegar A. You have titration 1, titration 2. Record the burette readings in table 2.1. Complete table 2.1 with the volume used in each titration. So for titration 1, final burette reading, it's 24.1234 5 6 7 8 9. 24.9 should be 24.9. What about the initial reading? It's 0. So we write 0 here. Titration 2, final burette reading is 37.1234 37.4. So I will write 37.4. What about initial reading? 12.123 should be 12.3. Volume of A used per centimeter cube in titration 1 should be 24.9, because you have to subtract the initial volume from the final volume and you will get 24.9. What about titration 2? You have 37.4 minus 12.3. 37.4 minus 12.3. You'll get 25.1. Moving on to next part. Number 2, figure 2.2 shows the burette readings for one of the titrations with vinegar B. Here's titration 4. We have initial and final reading. Figure 2.2, record the burette readings for titration 4 in table 2.2. Calculate the volume of vinegar B added in titrations 3 and 4. Here's table 2.2. For titration 3, they have provided us the final and initial burette reading. Final reading is 12.6 and initial burette reading is 0.1. So if you subtract 0.1 from 12.6, what you will get? You will get 12.5. What about titration 4? Final Buret reading 25.123. So you have 25.3 here. So I will write 25.3. Initial reading 12.12345 12.6. So I will write 12.6. In order to get the volume of B used for titration 4, we need to subtract 12.6 from 25.3. So the answer will be 12.7. Calculate the mean volume of A and of B needed to neutralize 25 centimeter cube of 0.4 mole per dm cube aqueous sodium hydroxide. Mean volume of A. So we have 24.9 and 25.1. 24.9 plus 25.1. So in order to get the mean, we will divide it by 2. 24.9 plus 25.1 divided by 2 will get 25. What about mean volume of B? We have 12.5 plus 12.7 and then we'll divide it by 2. 12.5 plus 12.7 divided by 2, we will get 12.6 as of mean volume of B. C. Suggest why the titrations using A and B are repeated. So we need to check that results are consistent, so that the results are consistent. We need consistent result. D. The equation for the reaction between ethanoic acid and sodium hydroxide is shown. This is a reaction CH3COOH plus NaOH gives CH3COONA plus H2O. The answer to B shows the mean volume of B used to neutralize 25 centimeter cube of 0.4 mole per dm cube aqueous sodium hydroxide. Calculate the concentrations of ethanoic acid in B. Give your answer to an appropriate number of significant figures. Now we have mean volume of B. What is the mean volume of B? It is 12.6. So I'm writing the mean volume. (12.6 centimeter cube). Other information which are provided in this question is the number of reacting moles. If we will consider the number of reacting mole of ethanoic acid as N1 for ethanoic acid, it's according to the equation 1 mole. What about the volume of ethanoic acid? It's provided 12.6, and we need to calculate the concentration, which is M1 is equal to sodium hydroxide. The reacting moles for sodium hydroxide is also 1. N2, I'm using N2 for sodium hydroxide, so I will write 1 mole for N2. What about the volume of sodium hydroxide? It's also provided. You can see it's 25 centimeter cube, so I will write 25 centimeter cube. M2, it is also provided, which is 0.4 mole per dm cube, so you'll write 0.4 mole per dm cube. Now we have the equation can use this equation in order to calculate the concentration of ethanoic acid. M1 V1 by N1 is equal to M2 V2 by N2. N1 and N2 will be cancelled out as both of these are of one one moles. So now we are left with M1 V1 is equal to M2 V2. We need to calculate M1. Rearranging the equation, we will get M1 is equal to M2 V2 by V1. Placing the values, M2 is 0.4, V2 is 25. What about V1? V1 is 12.6. 0.4 multiplied by 25 divided by 12.6. We will get 0.793. You can even write 0.794. So we will write 0.794 because in the question they are saying you have to write appropriate number of significant figures. So I will round it off to 0.794. E, use your answer to D to calculate the mass of ethanoic acid in 500 centimeter cube of B. MR of ethanoic acid is provided, which is 60. So first of all, I need to calculate the number of moles of ethanoic acid in 500 centimeter cube. So the concentration is 0.794 mole per dm cube, which means it is in 1000 centimeter cube. So I will write 1000 centimeter cube contains 0.794 moles. Therefore, 500 centimeter cube contains X moles. Do the cross, we will get X is equal to 0.794 multiplied by 500 divided by 1000. So what we will get? 0.794 multiplied by 500 and divided by 1000. We will get 0.397. So 0.397 will be multiplied by 60. So the mass will be 23.82. So you write 23.82. Because I have multiplied the moles by the MR in order to get the mass. Remember this formula. In order to get the mass, you need to multiply the moles by the MR. These are the moles we obtained, 397. Number F. Use your answers to B and E to calculate the mass of ethanoic acid in 500 centimeter cube of A. What about the mean volume of A? It is 25. So using the same formula, if you use the same formula, M1 V1 is equal to M2 V2. So M1 is for the concentration of ethanoic acid. I will write M1 is equal to M2 V2 by V1. M2, see it again, 0.4 M2 and volume is 25. 0.4 volume is 25. What about the volume of A? It is also 25. The volume of A is 25 centimeter cube, the mean volume. So these will be cancelled out. So the concentration is 0.4 mole per dm cube, which means 1000 centimeter cube contains 0.4 moles. Therefore, 500 centimeter cube contains X moles. So X is equal to, do the cross, 0.4 multiplied by 500 divided by 1000. 0.4 multiplied by 500 divided by 1000. 0.2 moles. In order to get the mass, multiply the moles by MR. So 0.2 multiplied by 60. 0.2 multiplied by 60, and we will get 12 gram. So this will be the final answer. G. Suggest why the conical flask is rinsed with distilled water and not 0.4 mole per dm cube aqueous sodium hydroxide between titrations. So distilled water is used to remove any chemicals present in it. We can't use NaOH because definitely some of the sodium hydroxide would remain in the flask and more ethanoic acid would be needed. So you can write any two from these statements. Any two from distilled water used to remove any chemicals from the flask. We can't use NaOH because then some NaOH would remain in the flask. Last, again, you can't use NaOH because more A or B ethanoic acid would be needed. H. Some vinegars are brown rather than colorless. Suggest why this titration method would not be suitable for finding the concentration of ethanoic acid in brown vinegar. The color change couldn't be clearly observed. Question number 3. Student investigates solution W and copper 2 carbonate. A. The test the student does on W are shown in table 3.1. Some of the observations for these tests are also shown. Here's table 3.1. So number 1, add aqueous sodium hydroxide to W. Solution remains colorless. Number 2, add dilute nitric acid, then add aqueous barium nitrate to W, white precipitate. 3, add dilute hydrochloric acid, then add aqueous silver nitrate to W, white precipitate will be obtained. Flame test on W. No color is observed. Number 1, the student correctly concludes that ammonia is formed in test 1. Describe what else the student must have done to reach this conclusion. He definitely has warmed the solution and test the pungent gas produced with moist or damp litmus paper, which will turn to blue. So we will write warm the solution. Test the pungent smell gas. Ammonia is pungent smell gas. In this case, with moist or damp litmus paper. Paper turns blue. You can check the test from this qualitative analysis list. You see the test for gas here, ammonia. It's turning damp red litmus paper blue. Number 2, state why the student cannot identify the anion in W from the observation in test 3. So look at the statement. The student has added hydrochloric acid and we are getting white precipitate with a silver nitrate. Here's a test for chloride ion. This chloride ion. It will definitely give white precipitate with aqueous silver nitrate, but when you are acidifying the solution with dilute nitric acid, not with hydrochloric acid. So if you add hydrochloric acid, it will also contain chloride ion. So that's why you cannot identify the right anion in W from the observation in test 3. So you write hydrochloric acid also contains chloride ion. Cl negative or chloride ions. Number 3, state how the test and observations show that W does not contain sodium ions. So for sodium ions, what is the test? Here's a test for sodium ion. Here's sodium. It will give yellow color. Flame test, sodium ions would give a yellow flame. Number 4, identify the cation and anion in W. Looking at the observation, obtain number 1, it's indicating from this information, ammonia is produced, that it must contain NH4 ion, ammonium ion. What about the next ion? Number 2, when you are adding dilute nitric acid and aqueous barium nitrate, we are getting white precipitate. So this test is for the sulfate ion. You see this? Acidify with dilute nitric acid, then add aqueous barium nitrate, white precipitate. So definitely it must contain ammonium and sulfate ion. Ammonium, which is the cation here. Ammonium, not ammonia. Ammonium or NH4, positive. Sulfate or SO4 minus 2 or 2 minus. B, the student adds dilute hydrochloric acid to copper 2 carbonate. A gas and a solution are produced. You are getting a gas and solution is also produced. Number 1, state the observation that confirms the production of a gas. Whenever gas is produced, you will see effervescence or bubbling, fizzing. So we'll write fizzing or effervescence. Number 2, describe how to do a flame test to confirm the presence of copper-2 ions in the solution. So you have a workable method, that is, take a glass rod and make a paste of the solution, solution of the salt with hydrochloric acid. Then bring it to blue flame and you have to notice the flame change. Flame changes color. And in this case, we'll get, what color we'll get for copper? We must get blue-green for copper-2 plus ion. So you can write any workable method. Like make a paste of copper-2 carbonate with dilute HCl, dip a glass rod and bring it to blue flame of Bunsen burner. Flame changes to blue-green. Number 3, describe one other method the student could use to confirm that the solution contains copper-2 ions. So test for the cations. Where is copper-2 ion? We have copper-2 plus ion here. So we have the test with sodium hydroxide, aqueous sodium hydroxide, and with aqueous ammonia. In case of sodium hydroxide, it will give light blue PPT, which is insoluble in excess. And in case of aqueous ammonia, it will give light blue PPT, soluble in excess, giving a dark blue solution. So we'll write any of these tests, for example, with any one of these. Aqueous sodium hydroxide, blue PPT, blue PPT insoluble in excess. Or you have aqueous ammonia, it also again gives blue PPT. In excess solution, in excess, dark blue solution will be obtained. Solution will be obtained. Last question. Baking powder is used to make cakes, rice. When water is added to baking powder, carbon dioxide gas is released. The longer the baking powder is stored, the less carbon dioxide it releases when water is added. Plan an investigation to show which of two different samples of baking powder has been stored for longer. Your plan should include the use of common laboratory apparatus, the two samples of baking powder and water. No other chemicals should be used. Now, your plan should include the apparatus needed, the method to use, the measurements to take, the variables to control, how to use the results to determine which sample has been stored for longer. You may draw a diagram to help you answer the question. Now, in this question, so it's of 6-mark question, I think. Yes, it's of 6-mark question. So how these marks are divided for this question is that you can write one for these, one you can draw a diagram for balance test tube or conical flask. Even you can draw the equipment used to measure the volume in order to get the 1 marks, but you have to label the apparatus. For method and measurement, you can write one of these statements, like you are measuring the mass or amount of the sample, then you are adding water, then you are measuring the volume of gas produced, or measuring the time to turn lime water milky, because lime water test is used to check the presence of carbon dioxide gas. Then in case of control, you can write any one of these, like you must have same mass of each sample, or you can calculate the change in mass, same volume, see the change in volume per gram. You have to calculate this. It should be carried out at same temperature. Then you will measure the total volume of gas produced when there is no further change. Or you will measure the volume of gas produced in a fixed time. The last one is using the result. The sample which produces more gas, which means it has more bubbles, it will take less time to turn milky, or is milkier, which means it is stored for less time. Or you can have opposite statement. When the sample is producing less gas, it will turn milky and taking more time, which means that it is stored for a longer period. This will cover 4 marks. For the other 2 marks, you can draw one more apparatus and write one of the statements which I have just explained. So first of all, I will start with the statements. So for the method and measurement, you can write measure a mass. Let us write it 1. And for control, I'm writing it 2. And last one, 3. For 1, anyone, measure the mass, measure a mass or amount, adding water, excess water, measuring the volume of gas produced, or measure the time taken to turn lime water milky. For number 2, again anyone from these. So you must have same mass of samples, same mass of each sample. You can even write amount, or you can calculate the change in mass volume produced per unit. Here will be gram because the samples are in the solid state. Or you can have same temperature. This will be carried out at same temperature. There won't be any variation in the temperature. Then you can even measure the total volume of gas produced. Total volume of gas produced. Or you can measure the volume of gas produced in a fixed time or in a fixed time. Number 3, anyone? That is for the results, using the results. So sample that produces more gas, more bubbles, sample that produces more bubbles will take less time to turn lime water milky. Is stored for less time. For less time. Here you have lots of bubbles, or vice versa. The opposite statement will be the sample that produces less bubbles will take more time to turn lime water milky, which means it is stored for longer period of time. Now coming to the apparatus. Now what apparatus you can draw? You can draw the balance. If you want, you can draw the balance here, or you can draw the test tube. I'm drawing the test tube here, but you have to label the diagram. This is test tube. Or you can even draw conical flask. This is conical flask. Or you can draw a beaker. This will be the beaker. Or equipment to measure the volume of gas produced. In this case, you have gas syringe. Okay, that's all for this question. Thanks for watching. Press like and share my videos. For more videos, subscribe to my channel and press the bell icon.